Momentum. In this video, we'll be looking at momentum and also introducing the concept of impulse. The term momentum is actually a scientific term in physics, and it's associated with moving bodies. For example, in football, we might say that a small player requires a lot of momentum to tackle a big player. We might also say that a train has a lot of momentum as it is really hard to stop. So if momentum is a physics term, what exactly is it? A good picture of momentum is a measure of how easy it is to stop that body. So let's look at an example. What's harder to stop? A train moving at 5 k's an hour or a bike moving at 5 k's an hour? So the train would be harder to stop, which suggests that momentum is based on mass. So the larger the mass, the larger the momentum. So another example, which is harder to stop? A cricket ball moving at 5 k's an hour or a cricket ball moving at 20 k's an hour? So the cricket ball that's traveling faster would be harder to stop. This also suggests momentum's got something to do with speed. The greater the speed, the greater the momentum. So we can put these together and come up with a definition. So momentum is defined as a product of an object's mass and its velocity. Momentum is a vector quantity, meaning direction is important, as well as its magnitude. Alright, the units of momentum, because its mass and velocity, is kilogram meters per second. Although later on, there are a few other types of units that we can use for momentum. Alright, now we're going to investigate how momentum relates to the force of an object. So Newton's second law of motion states that the acceleration of a body is directly proportional to the force acting on it. So that's F equals ma. However, using the definition of acceleration being the change in velocity over time, which is this one here, we can substitute that definition of acceleration into Newton's second law, which gives us this result here. Okay, now just with a little bit of maths, we can rearrange the top line so that we have the mass term associated with the velocity, the final velocity and the initial velocity. And simplifying further, we can see that the force of an object depends on its change in mass times velocity divided by time. And what we just found earlier is that mass times velocity is the momentum. So this means that we've found a relationship between force and momentum. The force of an object is directly proportional to its momentum and inversely proportional to the time it takes to stop. We can rearrange this equation for the change in momentum, and we can give it the term impulse. So the change in momentum is known as impulse. So investigating this equation a little bit, we can see if we have a really large change in momentum, it requires a very large force or a large amount of time. And you can relate this, for example, to stopping a train, where a lot of force is required to stop a train, or if you only provide a little bit of force, such as the brakes on the train, it might just take a little bit longer. Alright, the question for this slide, explain why it is possible to catch a thrown egg without it breaking using the concept of impulse, and use the words force, change in momentum, and time.